What's up, guys? Back at it, day 2 of your lessons, and we are going to keep going with this learning target 2. We are just going to add a couple small little tidbits to what we learned on our last lesson. So here's what we're going to talk about. We're going to talk about protons, neutrons, and electrons again. And the big deal today is we're going to talk about ions. So previously we learned that the protons are equal to the electrons, right? If it's neutral. So the positives are equal to the negatives. Well, in an ion, the positives are not going to be equal to the negative. We're going to have a charge. It's going to be positive or negative. So the protons are not equal. All righty. It's a gain or losing of electrons. And all we do to indicate this is by adding a subscript or associated with it. So in this case, you have an elemental sodium right here, which has got 11 positives, always got 11 positives, and it's got 11 negatives. All right. If this little electron decides to leave, what happens is we lose a negative and it becomes positive. So I have 11 protons positive and 10 electrons. Now this just kind of becomes a cancellation game with how many are left over. So if I had 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I only had 10. Okay, well, there's one positive left over, i.e. the positive. Okay, so that's kind of really what you got to be thinking about. If you go to your worksheet, all right, if you go to your worksheet here, atoms are ions, meaning they have no charge. They have charge, excuse me. So the number of positively charged protons are equal to the negative, are not equal to the negatively charged electrons. All right. So let's just take this for example. All right. You have 92 protons. Uranium has 92 protons. All right. You can always find the number of protons, remember, with the atomic number. Uranium right here always has 92. So in a neutral element, guess what? The electrons would be 92, but it's not neutral. So we say it's got 90. All right. So it's got 90 positives, or 92 positives, 90 electrons. What's left over? Plus 2. There's 2 protons left over. All right. Let's go to fluorine. It's got 9 protons forever and for always. 10 electrons. What's the charge? -1. All righty. If we keep going with this, on your worksheet 2, is there more protons and electrons with the atom that will be, if there's more protons than electrons, the atom will be positive. If there's more electrons than protons, the atom will be negative. A key point is this: you can always change the number of electrons, you can never change the number of protons. Every element on this will always have this many protons no matter what. You can never change that. Copper, for example, has 29. Always has 29 positives no matter what. It could have 30 negatives, 30 electrons. It could have 27. It could do whatever it wants, okay? But an important thing to know is you can never change the number of protons. You can only change the number of electrons. Alrighty? We'll keep going. Here you go, copper. Boom. What do you know? Got 29 protons. How'd you figure that out, Mr. Tyson? Aha. Handy dandy periodic table. 29 protons. Bingo. Okay. 27 electrons. Well, 29 positives, 27 negatives. That leaves me with the +2. Go ahead and do these 2 right now. Sweet. All right, now we're on to our chart. So the same stuff is kind of what we did yesterday. Last lesson, mass, doesn't matter. Now it's going to get a little complicated because you got a lot of boxes. This is always protons plus neutrons, all right? Never changes, ever. Mass is protons plus neutrons. The only thing that's going to change now is the number of electrons and protons. So let's look at chlorine, all right? So the element is chlorine. Let's just do the mass, all right? So 35 minus 17 is 18, right? All I did was just, hey, 35 is the mass, 17 subtract it over. All right, now let's move on to the charge. Now I always like to do this, okay? Protons and electrons are paired. So I have 17 protons, 18 electrons, all right? It is a -1. It is what we call an ion. They are not equal, okay? And this can be indicated here in the symbol. See this little dash? That would mean it's a minus, right? That's a little how we indicate like a sub or superscript. Let's do number 3. You can do number 2 on your own at the end. Do number 3. That is potassium. Alrighty. What's its mass? Well, 19 plus 20 is 39. Yay. And now let's go to the number of electrons. Now, if I look here, this is positive. I can't change that. So then what I have to know in my head is I just kind of go to the electrons and say, well, I'll have 18 negatives. That'll give me 1 positive left over for a +1. A rule of thumb, just kind of help yourself. Whatever the symbol is, do opposite to the electrons, if that makes sense. So, okay, well, it's supposed to have 19, but it's a positive, so I'm going to take away 1. Alrighty, so there you go. You got 3 more problems there. Just working on your charge. Finish this worksheet up, turn it in, and that is your lesson for the day. Pretty short, pretty sweet, and it's just building on what we did the other day. Let us know if you got any questions. Love you lots.